Hi there, folks. Today we're looking at Law of Cosines. We've already talked about Law of Sines, and just like Law of Sines, Law of Cosines, we don't need a right triangle. That's what's special about this thing. This is where we want to use this, all right? If we had a right triangle, of course, we're just going to use our regular trig ratios, our regular proportions that we would normally use. We don't need anything special, all right? But when we don't have a right triangle, we can use this special law, the law of sines or the law of cosines. Now, the law of cosines looks a little bit more complicated, but once you understand the format of one of these things, all three of these say the same thing. So when we look at this, really you don't need all three of these, okay? They're saying the same thing. Essentially, it's set up kind of like the Pythagorean theorem, that a squared plus b squared equals c squared kind of setup. And then the second half of this thing is 2bc cosine of a for this first one. Really, here's how we fill in these pieces, all right? Whatever we have here, this is one of our sides, and it's squared, okay? And then it equals the other two sides, so the two sides that weren't this guy, squared, being added together, minus, well, now it's the same sides over here being repeated. The 2bc, all right? It's the same sides that were being added, and then it ends with cosine of a. All right. And so if we think back to our law of sines, the law of sines talked about the sine of the angle versus the opposite side. And when you look at this guy, we have similar components to that. Notice we have the cosine of angle A, and over here on the other side of this thing, we have the opposite side. And so that's what I kind of always start with when I think about the law of cosines. So always think about the angle that I'm going to use, and then the opposite side. And that gives me kind of like the bookends for this thing, all right? Likewise, in this guy, I look at the same thing. I say, okay, if I'm talking about cosine of b, if I'm talking about angle b, then over here I have to have the opposite side squared. And then from there, I just fill in the rest. It's the other side squared minus 2 times the other sides, okay? And it's the same thing with the next one right here, cosine of c. So if I'm using angle c, the opposite side goes over here, and I square that thing, all right? And now the rest of this is fill in the other two sides squared, all right, being added together, minus 2 times the other sides, all right? And so that's kind of how I remember this. I don't memorize this exact formula. I remember the pattern of the formula, all right? And if you remember the pattern, you don't need all of these. You only need one of them. Okay, most students find it easiest to think about this guy because they have their a squared plus b squared equals c squared. So that's one chunk of it. You kind of model the Pythagorean theorem. Even though c doesn't really represent the hypotenuse this time, it represents the side that's opposite the angle that's over here. All right, and if you kind of remember that, if you just think of c as the opposite of the opposite side of the angle, and then you can remember the, hey, c squared equals a squared plus b squared, like your Pythagorean theorem. Now really it's just a matter of remembering this piece, the minus 2ab, minus 2 times the sides that are not by themselves, the same two sides that I have over here, okay? And so, again, one of the things I think makes this difficult is just remembering the formula. All right, remembering the formula can be a little bit tricky. And again, when I start with this thing, the thing that's unique, notice we use all three sides here, all right? But the thing that's unique is going to be the angle. I only use one of the angles. And so that's kind of what I'm going to start with when I start to investigate these, all right? For example, let's take a look at one. If I look at something like this guy, in terms of just setting this thing up, in terms of which side is A and which side is B and which side is C, all right, really A, B, and C are interchangeable. It depends on which format I want or which format I need. And really it depends on which angle I have or which angle I want, all right? And so again, we're going to use all three sides no matter what, and it's arbitrary in terms of which one I call A, B, and C unless I identify the angle first, okay? And so when I look at this, the only angle I have is this one, and notice the side opposite that angle is side X. So essentially, now I've established that I'm going to use that as my C value. That's how I figure that out. Because again, when you think about the formula here, it always ends with the cosine of some angle. And this time I'm going to do the cosine of 40, which means over on the other side of this equation, it has to be the opposite side. It has to be the side that's opposite that angle. Whatever angle I use in cosine for my law of cosines, I have to have the opposite side over here, so x squared. Okay, and so that's kind of where I start. I always start thinking about the angle, because once I think about the angle, if I decide, hey, this is the angle, 40 is the angle, well, then the opposite side goes over here. And now the rest of this, I just fill in the other two sides. And so the other two sides, it doesn't matter which one's A and which one's B. So I'm going to do 2.5 squared plus 3.5 squared minus 2 times A, 2.5, times B. And I didn't quite give myself enough space here. I did my best. I took a guess. I didn't quite get there. Okay? And that's it. I have this whole thing. And notice one of these sides is something I can completely plug into the calculator right here, this guy. That's something I can completely plug into the calculator. And then to solve for x, I'm just going to take the square root of each side. And so again, when you look at this, this looks complicated if I take the square root of each side. So if I take the square root of each side, that's going to be really tough to plug in the calculator, maybe all in one string, all right? Especially with the square root and kind of figuring out parentheses. Students get lost when you do this, but really it's not so bad. If I start with what's inside the square root, if I just work my way across, 2.5 squared plus 3.5 squared minus 2, and I'm just going to copy this exactly the way it's written, times 2.5 parentheses 3.5 times the cosine of 40. And now I'm going to hit enter. And now that's what's under my square root. I want to take the square root of that. So I hit my square root button, and this is where I use that answer key again. So the square root of the answer to plug that back in. And really, I could say the square root and then literally type in the 5.094222, but we want this to be accurate. So make sure you punch in the whole thing if you're going to do it that way. Just use the answer button on your calculator. And so I get 2.26. And that's going to be the side of the triangle TE. And when you think about that, it makes sense, 2.26. When you think about the relationship between the sides of the angle and the opposite side, all right, this one's probably I guess in this case, the smallest angle. Again, this one's not drawn to scale, but it's in that range of the other two. So it seems to make sense within the context of this. The other question that students typically ask here is they look at this and say, well, why wouldn't I just use my law of sines? Because law of sines is so much easier. The problem is I don't have a completed ratio. And remember, when we did law of sines, I always said, hey, start with the ratio that you have all numbers, where there's no variables. And when you look at this one, that doesn't exist here. Okay, so if I tried using law of sines, I would say, oh, it's the sine of 40 over x. And then the next one, it would be something like the sine of angle E, which I don't know what it is, over 3.5. And so you see the issue here is I have too many variables. I don't have a completed ratio, okay? I can only use law of sines when there's an angle measurement and a side measurement across from each other that are both given. All right. And if I don't have an angle measurement, a side measurement across from one another that are both given, then I can't use my law of sines. All right. And so that's why with law of sines, I always said, hey, start off with the ratio that's all numbers. If there is no ratio that you can construct for law of sines that's all numbers, well, then you can't do the law of sines. Okay. If I look at the next one here, again, same kind of thing. I'm going to start with the angle. I say, hey, the angle that I have here is the 20. So in terms of cosine at the end of this thing, it's going to be cosine of 20 degrees. And so that kind of sets me up for the rest of this thing. If I'm using cosine of 20 degrees, the opposite side is the 5. So that goes over here. And I fill in the other sides. It's 7 squared plus x squared minus 2 times 7 times x. Times the cosine. This time I give myself way too much space. I'm really bad at this, apparently. Apparently guessing how much space I need is not my thing, all right? That's not what I'm good at, all right? I must be talented in other ways, all right? And so when you look at this thing, notice this time the x isn't the thing by itself. Well, that's okay. I just have to solve this thing, all right? And to solve this thing, this one's a little bit of a bear. All right, and so to go to solve this thing, let's just simplify what I know. I know the 25, I know the 49. And so what I have here is a situation in which, as I look at this thing, I have a quadratic. And so when I look at this, here's x squared, here's x, okay? And so if I kind of write this as a quadratic, get everything on the appropriate side, I do x squared, it's minus 14, and maybe I'll write it like this, cosine of 20, that's like the coefficient, and then times x. And then if I subtract the 25 from each side, that's going to be a plus 24. And now it'll be equal to 0. And so if you look at this, this is set up like a quadratic, and look at that middle coefficient. That's nasty looking, okay? And that's going to be a real pain when you go to solve this thing. The only way to solve this one, if I'm doing my law of cosines, is to use the quadratic formula here. And look at my a, b, and c. Here's my a value is 1. My b value is this whole thing, and my c value is this guy. So if I did my quadratic formula here, I'm just going to start to set it up, and then we'll stop. We'll kind of throw in the towel on law of cosines here. But I would do opposite of b, so that would be 14 cosine of 20 degrees, plus or minus the square root of b squared, minus 4 times a, which is 1, times c, which is 24, all over 2a. And now from here, all it is really punching into the calculator, and I only have to do the positive version of this thing. So let's plug it in. So to plug this guy into the calculator, here we go. Ready? 14 cosine of 20 plus, actually, I'm going to start inside the, so to plug this guy into the calculator, watch this, I'll plug it in here, ready? I'm going to start inside the square root here, and I'm going to say, okay, I've got a negative 14 times the cosine of 20. Well, I guess I could just, I could hit enter there and then square it. And then minus the 4 times 1 times 24. And now I want to take the square root of that, and this is where I use my answer button. Notice I'm controlling order of operations. Now I want to do 14 times the cosine of 20. I'm going to put that in parentheses here. And I'm putting it in parentheses to make sure it understands that I'm closing out that cosine. And then plus my answer. And now divided by 2. And so I get 10.98. And so as you look at this one, maybe you're looking at it going, wait a minute, couldn't I use my law of sines this time? And you're absolutely right. You can technically use the law of sines for this one, and you could avoid the quadratic formula. But there is one catch. Watch this. So here I have this guy, and I have the completed ratio. So I would set this up as sine of 20 over 5 equals, well, I want to find x, but the problem is I don't know this angle, okay? The only other thing I have is the 7. What I have to do if I'm going to use law of sines, let me call this angle y, is I have to do it twice. I have to do the sine of y over 7, and now I'd have to cross multiply and solve, and I'd have to find the y value. Once I have y, I can then figure out what angle A is, and then I just have to do my law of sines again, okay? So really, it's kind of one of these things where you kind of have to pick your poison here. You either have to do the law of sines twice, okay, because that's really the only way to get to the thing we need, or you have to do the law of cosines, but you're going to have to deal with the quadratic formula. Okay, so either one is acceptable here. Most students would choose the law of sines here and just do it twice. Okay, law of cosines works, but yeah, it's a little tough to plug in. Okay, if I look at this guy, once again, I'm going to start with the angle. And I'm not given any of the angles here, but I am looking for an angle. So that's the angle that I care about. That's the one that I want to use. And so once again, in terms of this thing, I'm going to do cosine, well, of x. And that still helps me fill everything else in. If I'm using x as the angle, the opposite side is the 5. So that's what goes over here, the 5 squared. And I fill in the rest. So let's see, it's 6.2 squared plus 7.8 squared minus 2 times 6.2 times the 7.8. And look at that. My spacing was perfect this time. Third time's a charm. And now I can solve this thing. Okay? And so what I do here is I just simplify a little bit. All right? Obviously, I can simplify the 5 squared, which is a 25. These other guys, I'm just going to plug these into my calculator, the 6.2 squared plus the 7.8 squared. That's as far as I can kind of take it. I can't subtract the other stuff. I can simplify it a little bit, so I can do the 2 times the 6.2 times the 7.8. So I can get a minus 96.72. But I can't do the subtraction yet because I haven't finished doing this multiplication. So be careful in terms of order of operations. Okay, I can't do this subtraction because there's still multiplication to be done. And really, I can't actually do that multiplication. All right. And so as we kind of look at this thing, I just have to work backwards through order of operations. I have to solve, which when I think about it, I have this guy and I have multiplication and then I have the cosine. I'm just going to undo those kind of in reverse order here. I'm going to subtract the 99.28 from each side. Okay? And again, use your calculator for this. It gives me a negative 74.28 equals the negative 96.72. Sorry, I should be showing this on the calculator. I mean, I'm going to need the calculator here at some point. I guess I don't need it yet. Let me divide each side by the 96.72. This is where my calculator is going to come into play. Again, I don't even need to actually do this yet. I'm just going to leave it like this for a second. Granted, the negatives cancel each other out. Equals the cosine of x. And now to undo cosine, I do the inverse cosine. Okay, and again, anytime you're solving for an angle, you're going to have to do inverse cosine. All right? And notice I didn't bother punching that in yet because, well, my calculator's going to do all the work anyway. I might as well just wait and punch it in all in one shot. Let me put it up here. So x equals. So I do inverse cosine. I use the parentheses. The parentheses will help me divide. We'll keep the division inside the cosine, so it's not outside the cosine. I get 39.8, and that's degrees. Okay? And that's it. All right? And again, it's always going to be the same couple steps when we solve this thing. Combine the squareds, all right? Subtract, divide, take the inverse cosine. If I take a look at this last one, this one's interesting because you go to set it up. So we'll watch what happens here. So if we're kind of thinking about law of cosines right now, so we take this guy and we say, okay, there's x. So it's the cosine of x. And then we go to fill this in and we say, okay, the opposite side, well, I don't know what the opposite side is. Maybe I'll call it y. And so now all of a sudden this is y squared. And hopefully you're already going, well, this is going to be a real problem for me, Mr. Jansen. This is not going to work, okay? And you're absolutely right. This is not going to work. The problem is I have too many variables. I can't solve this equation because, well, I got a y here and an x here. This is impossible. So maybe you think, okay, well, maybe I should try finding the other angle. Maybe I'm finding the wrong thing. So maybe I'll switch this up and I'll say, okay, let me try again here. Maybe I'll call this angle r. I'll do like a lowercase r here. So I'm going to do angle r, so cosine of r. And now I don't have the issue over here. The opposite side is the 7, so 7 squared. But as I go to fill this in, ready? 9 squared plus y squared. Well, right away, this is a problem, okay? I have too many variables here. It's not going to work. And so the key to this one is you shouldn't be using law of cosines at all right? And so the idea here is we have to really think which of these things I want to use, all right? And when you look at this one, notice I have the completed pair, okay? I have this completed match right here of this guy and this guy. That tells me that maybe I could try something like law of sines. All right. And for this particular example, I can't actually find x in terms of law of sines. So if I do sine of 115 over 9 equals, if I try to do x, it's the sine of x over, well, I still don't know. It's the sine of x over y. Well, here's what I can do. I can find this guy. I didn't label, I erased the label, but r. Watch this. I can do sine of r over 7. And see, that is a ratio that I can solve. So I cross multiply, I solve this thing. Divide by the 9. And then I'm going to take that inverse sine of each side. So then I get rid of sine, I take the inverse sine. And you might be looking at this going, well, this isn't even solving for the thing I want. But basically, once we solve for this angle, we're automatically going to have the other angle. So once again, this is a job for my calculator. Let's see, 7 sine of 115 divided by 9. And then I want to do the inverse sine of that answer. So I get a 44.8 degrees. And if you're looking at this thinking, okay, well, that's still not the thing that I wanted. Well, that doesn't matter because look at what we have now. 44.8, the 115, I can easily find the missing angle. Remember, they all have to add up to 180. And so this guy plus the 44.8, that gives me a 159.8. So all I'm missing is a 20.2 degree angle. Okay. Sometimes, depending on what's given, you won't be able to go right to the thing you're looking for. You might have to find another piece. Okay. And the other thing is this, make sure you're looking for that completed ratio for law of sines, because law of sines tends to be easier. Okay. Use the law of sines when you can, find whatever you can, and then use that to find the remaining pieces. Okay? If you can't use law of sines, if you don't have that completed ratio, that's when I would suggest going to law of cosines. Okay? And then we can kind of work that out and see if I have enough information. Okay?